I'm Anna. I work at Hive. We're a smart homes company based down in London. And we have done a huge revamp into React Native from our native apps last year. And my job for the last about 6 months was trying to figure out how to make it fast. And it has been unbelievably difficult. Performance is a really important topic, obviously, for everyone, from business to developers. We want to make fast apps. But React Native is also quite infamous at making it quite difficult, especially for older Android devices that can become very tricky. And I've done this talk several times, and two things always happen afterwards. The first thing is someone comes up to me and asks me, where are the tutorials and materials that I've been using? And the truth is there are none. Nothing exists. There is the React Native performance page that will mention maybe like 2 or 3 things, but there is no single source of truth. And everything I've been talking about over the last month or so is just trial and error and a lot of sort of painful findings. So that is something that I would like to share with you. The second thing that always happens is someone comes up to me and explains to me that I'm doing something wrong. So every single time I'm updating the presentation based on what someone told me last time. So I'm fully expecting to do another talk in 2 weeks' time again. But the truth is I have no idea what I'm doing. I was just told one day, we need someone to look at performance, will you do it? And I was like, yeah, okay, I can try. So everything is work in progress, as I mentioned, and my hope for today is to show you some patterns that are quite React domain agnostic, so they are useful for both web and React Native. And we found them through measuring and trying to figure out why things are slow. And I will also show you how to measure things, which I believe is very important, because every single app will have different problems. So if you can measure your own app and figure out why your app is slow, you will be able to make it performant as well without having materials and tutorials, hopefully. So the actual issues that we faced in our app were slow startup time, and the time to first interaction that was even after navigating. Animations were sometimes quite slow or jagged, and at times we had really slow response time to the user, so a user would click a button and then it would take 5 seconds for anything to happen, which was really annoying because it looked like the app has just crashed. So we decided to look at that first because it looked really awful on old Android devices. The problem is you just don't know even where to start. This is my representation of React Native because I'm running out of ideas of how to talk about the architecture. But essentially there are 2 threads and a bridge that communicates between them. There's the UI thread that renders things out into the UI, and there's the JavaScript thread that runs all your JavaScript. And there is a bridge that communicates between the 2 of them. It's essentially just a messenger. And when we were looking at slow navigation, we were really wondering at first what it might be. And our first gut feeling was pointing towards UI thread, because that is where the rendering is happening. Someone else also suggested that the React Native bridge might be struggling, and I've heard that a lot. But the truth is that vast majority of the time it is the JavaScript thread. You can figure it out quite easily by going into the developer options in React Native and clicking Show Performance Monitor. And you will see this sort of box overlay above your application that will give you real-time reports on what your app is doing or how it's handling the things. And the important boxes are the ones on the right, where you can see the frames per second for those 2 threads. So we want to be on 60 because then it looks seamless. But we realized very quickly that in the JavaScript thread, it's dropping a lot. Down to nearly 0 a lot, especially when navigating or doing animations. And suddenly we realized that that might be actually the issue, that we were looking into the wrong places. So this is a great first place to start when your React Native app is slow. Vast majority of the time it will be JavaScript, which is great because we're JavaScript developers mostly, so that makes it a little bit easier for us to handle it. Having said that, we knew our JavaScript was slow, and our first instinct was, to do that thing where you uncomment things or comment out things, and then you run it again, and suddenly it's much faster. It's great, but that doesn't really help at the end of the day because, then how long can you do this commenting out thing? So fortunately, there are different tools, and let me show you a practical example from our app. This is the dashboard. It's the first screen user hits when they load the app, and they have all their devices there, like heating and hot water and cameras and stuff. And this was very slow. There is a pagination, and when the app loaded, it was quite jagged when the user was swiping from screen to screen. And fortunately, because we didn't really have any idea why it was slow, we realized that there is this nifty tab in Chrome debugging tools and React Native debugger, which is called performance, and that allows you to measure whatever JavaScript is doing. And it gives you a flame chart. That needs to be a flame chart in every performance talk, right? And yeah, I see someone looking at it like, well, what am I looking at? And that's exactly the first thing you do when you see something like this. So I'll walk you through it so that you see what's going on. So there is the first column, which is just mounting the main application. And that has to happen every single time you start running your app. But it happens only once, it's fine. Then the next tiny column next to it is the rendering of the component. That's all cool. That's quite, slim, 2 columns. But then we've got 3 more columns. And we realize the JavaScript thread is doing something we don't necessarily need it to do. And we realize this is updating. And the flame chart essentially shows you then that all the way from the honeycomb component on the top, all the way down to every single cell and every single item on that cell, it re-renders every single time there is any change in state. And well, we realized that's probably a problem. So our main issue started being state change. I tried to understand why state change is a problem. I figured this out. When there is a change in state, we probably want something to re-render in the UI so that the user sees something different. But what it does is that React figures out which render functions to actually run. Then it runs them and creates a new virtual DOM tree. Then it reconciles the old DOM tree with the new DOM tree and figures out what to actually re-render. And then it does the re-rendering. Till today, I am not sure which part is the slow one. What we did figure out, though, was that if we don't change anything, we're not going to re-render anything, and that's exactly where we are going to head with this. So our ultimate solution to vast majority of our performance problems was stop re-rendering. Unfortunately, we built our app with a lot of preconceptions that were completely wrong, and we started having a lot of problems. The usual answer to how to make an app performant is use should component update. It is in the React docs. When you ask someone in an interview, they'll always say this. But actually, it is not that great. And it caused quite a lot of issues in our application. So after we got really excited about it and put it everywhere, we then ended up removing it from everywhere because it turned out that it caused many more problems than it solved. Let me show you a quick example. Let's say we have a component that has a name and a value. And I only want to re-render this component when the name changes. For some reason, I don't care about the value being up to date. So I add a should component update, and I say only re-render when the name changes. 6 months later, another developer comes in, needs to add a description, forgets about should component update, description does not update, and sure enough, we have a bug in the app. So our app is fast, but it's buggy, and that's kind of a bad combination. Sure enough, in an example like this, you can easily see the should component update, but when you have nested views, when you have a lot of props, it starts becoming really difficult to manage. Fortunately, React itself is super smart at figuring out when to re-render something if you work with it the right way. As I mentioned, there is a reconciliation process in React where it compares the old and the new, and then it figures out what to do with it. And it's a very relatively simple algorithm from top point of view. If you change a node type, like if you change diff into a span, it will destroy the whole subtree and remount it again. Obviously, we don't want to do that often. When a prop or state changes of a component, we will shallow equal the values, and if there is a change in that, we will want to re-render the component, and then it will also want to check all the children. So there is an important piece of information to remember here, that it always propagates down the tree. So if we change something on top level, it's going to cause much more problems than if we change it on the bottom level. a few practical examples. For the node type change, let's say I've got a wrapper of some kind that changed the wrapping component based on type. So if I change type, I will change from wrapper 1 to wrapper 2. And that means that the children will get destroyed and remounted again. So we don't want to do that, practically ever. And then the prop change it's a very simple one that you have seen so many times. If I change the text in the component, I would expect the button to re-render, right? It's a simple one. But there are a few problems with this. You probably know that if you mutate an object that is a prop, it's not going to re-render because the reference stays the same because there's only shallow equal. But similarly, if you keep changing the reference to the prop, it will keep re-rendering all the time, even if you don't want to. And as I mentioned, if you do a change on the top level of your tree, it will have to go down quite deep to figure out what else needs to change. So let's have a look at a few examples of how we're building components. The first thing to avoid is anonymous functions. We used them a lot because we are huge fans of arrow functions. What we did not realize is every single time I run the component function, it will create a new reference to the anonymous function and it will re-render the child component every time. So if there is a relatively complex child component, it will keep re-rendering and re-rendering for absolutely no good reason whatsoever. Fortunately, there is a very simple amendment. We usually turn the component to a class component using peer component to make it slightly more optimized and use it as a method. You can also just create it as like a named function outside of your component that works out fine as well. Either way, you probably noticed that there was a squiggly line. We even have an ESLint rule that is warning us against using anonymous functions these days because they absolutely needlessly make it worse. So avoid those. Tip number 2, how many of you are using Redux? Can you show me your hands? Cool, that's quite a few. I did this talk in, I think it was Helsinki, and there was Michel Westrade who created MobX. And after he saw my talk, he was like, well, you know, a lot of those problems would be solved by not using Redux. So, you know, if you don't need to use Redux, probably like think about something else. But for those of us who are stuck with Redux, let's have a look at how to improve it. React-redux has this connect, and you pass it some functions, and those functions map state or the store into your component to props. Map state to props is a simple one. It's just like connect state to props. The next thing is map dispatch to props, and unfortunately, this can be both an object and a function. And then there is merge props, and that's the ultimate evil because it always creates new references. So you can see here that what I'm doing in the merge props is I take dispatch props and the state props, and then I'm like sort of connecting them together, which is completely useless. It's just like it looks a little bit nicer than doing it in the component. But the cost of it is that every single time I change anything in the Redux state, this will get ran, the new references will get created, and everything will get re-rendered. Now, our store is really huge and it gets updated all the time. So you could imagine that our whole application was essentially like sort of like, you know, staggering along because it was constantly re-rendering through this. So first point of action is remove merge props. The next one, always use object for map dispatch to props. So that only leaves us with map state to props being ran and potentially returning new values all the time. But that can be also fixed. If we have a selector that, let's say, returns product info, we can optimize that. This is the unoptimized version, where you see that we find a product among products in the state, and then we either return an empty object for the info if product isn't found, otherwise we return the information. The problem is that this object gets new reference every single time, and so you re-render every single time. However, we can use memoization to offset this problem. We are using reselect, which has its own problems, but it does have memoization out of the box, which is quite nice. We can slightly restructure it so that when we are calling the getProductInfo this time, it only actually gets called when the products have changed. as a simple example, I was like hoping that I could like point at things, but I can't actually do that here. On the first line, you can see that the state is just empty. And I will get info, and it will probably give me empty object. And then I update the state with new products, and I get info again with the new updated state. And it will give me a different info, because obviously the products have changed. But the third time around, I'm just changing something in the user, and our product info does not care about anything in the user. So actually, info 2 and info 3 is exactly the same object, so no re-rendering happens. So memoization of your selectors is great, super useful. So I talked a little bit about how we're writing components, but how do we actually manage state itself so that it's not causing problems? The first thing is when we're using local state, we kind of want to avoid setting it based on properties. It's like quite a common pattern that you've got component update, and if some props have changed, you want to change state. But that means that you have literally just updated, re-rendered the component, and it will do it again once you set state. And that's twice in a row, and we definitely don't want to do that. So a better course of action would be using get-derived-state from props, where it just does this like whole cycle only once. But even better, I would say, is don't set state based on props at all. If you can set somehow whatever values you're expecting already in the props, it will be better. The next question always is, do we actually need to set state? We have a lot of these sort of flags in our app where if a user clicks something or something happens, we set something to true. But every time we try to do that, it will re-render again. So we are trying to protect ourselves from doing set state. I've also noticed that set state can be misused for sort of memoization on the fly. You know, like when you have something in render function that can be quite operation heavy. We think it's better to save it in state so that we can have it there for later. But again, that means re-rendering that is absolutely useless. So if you need memoization, memoize it outside of your component. Then, now that I said that you should not be setting local state, I will tell you, but if you want to set Redux state, always think whether local state wouldn't be a better choice. That is mainly for the reason that Redux state, as I already mentioned, affects every single connect and every single mapping you have in your application, and you definitely don't want to run that unless you really have to. So if there is something like modal and that kind of stuff, something that is relatively localized to one component, it's always better to think about doing it locally there. And then last but not least, if you do need to dispatch something into Redux store and you know that things will be, updated and re-rendered, always do it just once if you can. We had a problem on our startup of the application that we somehow grew it into 20 actions being dispatched on startup, and that was so slow. Mainly because it kept re-rendering everything all the time. So we decided to batch it up, which saved us, I don't know, maybe 5 seconds. It was like a huge win just by batching everything up. One more thing, someone asked here about context API and React hooks. Yes. Maybe you want to check out Nick Graf's talk from Helsinki, because he did a whole talk on don't use context API, it re-renders everything. So like we have seen that Redux state can do that as well, but if you use it in a smart way, it won't. But React hook context is actually built in such a way, and there is an article by Dan Abramov explaining why they did it that way, but it's built in such a way that it keeps re-rendering everything all the time. So replacing it with that, if you have any feeling that performance might be an issue, or like think about it twice. Last but not least, we thought originally that connecting like a whole screen with one connect would be ideal, because that way we won't actually have that much JSX, littering every place. Turns out it was a really awful idea, because what we did was we connected state on the top level, and then we had to pass props down to the children. So every time anything changed, we updated the whole thing. And that was just horrendous. So we spent weeks refactoring all our pages to connect state to the lower level components. And that was, again, a huge, huge performance win. So as you can see, practically all of this was just JavaScript, and those were our main wins in React Native application of actually running. It wasn't anything to do with animation or navigation or anything like that. Everything was just about the way we write React, and we thought we knew how to do it, but we learned the hard way that there were a lot of things still to learn. So the general conclusions are, it's nearly always the JavaScript, always measure before you act. That's the one thing that I actually should have listened to myself before this week. I'll get to it in a bit. Always think about how React reconciles things and how you do state updates, and memorize selectors as much as you can. That was the React bit. Now I've got like the native only bit. I don't know how many, could you just like do a quick show of hands again who's using React Native? Oh, that's quite a few, okay. So that's for you. There is the obvious one, animations. There's a reanimated library, which is quite popular. But we found that animated from React Native itself is quite good enough. As long as you use the use native driver flag, then it will kind of do the animation on the native side, and it's quite good. Then the next thing is images. They actually prove to be quite problematic for a lot of people, not in our app, but for a lot of people they caused issues. Fortunately, there is this great library called React Native Fast Image. It does caching for you, but mainly it has a much better implementation on the native side than the actual React Native image, and that is due to the fact that they are using the sort of optimized components from the native world. So this is the way to go. And it's literally just like a drop-in replacement. It's got the same API, so you just like import this instead of image and use that. Then routing was a huge thing for us as well. I said like a lot of the JavaScript stuff was, that solved a lot of our issues. But we made a huge mistake at the beginning of our project, and we just React Router native, which is like React Router JavaScript, just like done, slightly changed for the native side. But the problem is it's all done in JavaScript. And as I said, whenever you change anything in JavaScript, re-rendering takes ages. And this was whenever you changed root and you wanted to render a whole screen, there was suddenly this blocking action of trying to change the root. And it was absolutely horrendous. So then we had a whole discussion in our team of where to change to. We chose React Native Navigation, which is like a very super natively done nav, which is nice, but it hijacks React big time. Like the other day I had to look at the Java code for it and I was horrified. I'm sorry to the creators, but I'm not very happy with that implementation. So my recommendation would be to go with React Navigation with the latest one. I believe you need to combine it with React Screens, but then it's actually highly performant. It behaves in many ways exactly like native navigation would. But it's done for React Native, so it's actually it ties nicely with it. But the biggest thing was startup time, and Karen already mentioned this in his talk. On iOS, we found that was totally fine, but on Android, that has been my source of torture for like the last few months. And I actually thought I resolved it, and then I did a few measurements this week, and I realized it was all a bit sad. This is how I feel every single day. This is the sentence that runs through my head all the time. Like, I actually have no idea what I'm doing. Fortunately, I realized that the people at Facebook also don't really know what they're doing, so it's fine. When you need to debug startup time, you don't really have that many tools, especially on Android. You have to use profilers and systrace to figure things out. And we saw this in the systrace. And the important thing is the green line down there, which is the MQTJS, which is the JavaScript thread. And it showed us that during startup time, weirdly enough, it is the JavaScript thread yet again that is really struggling to keep up. And the problem is that when you click on it, and in normal systrace, it would show you what the thread is doing. But because this thread is like a long-running thread, it doesn't actually show you anything. It's like there's like a little bit of an information here and there, but it actually doesn't show you much. We found out that there are these things called React markers that the React Native developers put into React Native to sort of do a little bit of logging around what it is doing on startup time. So you can add this code to your onCreate function, and then you start seeing things like this. And you see it for every single native module you have. We realize that a lot of startup time is essentially just native modules being initialized. Weirdly enough, this is like literally what I copied today. So you've got create module start and end. You've got initialize module start and end. And then you've got, again, create module start and initialize start and end and end. And I have no idea why that is happening. And this is like my daily life. But we realized that between like create module end and create module start, like for the next module, there can sometimes be a gap. Sometimes like on the slower devices, it can be a second or a second and a half. I have no idea what the JavaScript thread is doing then. But we realized one like super smart thing. If there are fewer modules, then you have fewer gaps between them, and they initialize, like the whole startup time is faster. So our mission was to reduce the number of modules that we initialize. Yeah, pretty much like talked about this. But one more important thing is that we realized also that JavaScript execution actually starts halfway through the initialization of the modules. So actually it doesn't block our JavaScript, but it slows it down so much. So we realized that like the JavaScript rendering of our pages starts being very quick after all the modules are initialized. So essentially, we don't want the modules to initialize too much. First point of action, this is something super easy everyone can do in their React Native app if they have React Native 59, is go into metro.config.js and just flip the flag for inline requires. That way, everything will get actually inline required, and that means that instead of your like normal imports on top, they will sort of get passed by a bubble plugin into inline requires, so that no JavaScript code will run unless you actually hit that part in your app. So that's really useful. The next thing that the React Native team recommends is doing RAM bundling, which is yet another flag in metro config. It's very easy to set up, but it's not entirely reliable. It doesn't really work with code push. So although we are using it at our work, I'm not entirely sure that I can fully back it. However, there is this really cool thing called lazy package loading that you can do, and that changes everything. This is an example code from our Java code base, but essentially, instead of requiring normal React package, you require turbo React package, which weirdly enough is not turbo module. A lot of people confuse those two, but this is just a different way of loading packages. The same packages like as ever before. It's a little bit like, it's a lot of code. It's typical Java. You like need to write a lot of code for like very simple thing. But essentially doing this will mean that you don't need to initialize the module and create the module and get its constants until it's actually run. And together with inline requires, that's a really powerful combination, because you only require it when you actually need it. So I did all of this. I did auto inline requires, I did RAM bundling, and I did the lazy package loading for all of our 46 native modules. And then I put in a few logs to check what the performance gains were. So what I did was I added a check to on create, which is like the first part of your code that gets run on Android. And then we've got this hook after our dashboard gets rendered. So I put another console log there. The results did not amuse me. On Android 9, which is like the latest operating system, things were actually half a second slower than they were. On Android 7, they stayed pretty much the same. And on Android 6, like really old devices, it went down from 26 seconds to only 20 seconds, which, it's nice that it's 6 seconds slower, still 20 seconds though. And there was absolutely no change to our RAM consumption. So I was quite annoyed at that. That's like the latest finding from this week. And I realized that there is one point that I forgot about. We can do inline requires and all of these fancy things, but the way we write our code, yet again in JavaScript, it does not actually match the most performant way. Because the way we write sagas and reduces, we do it by features. I think a lot of us do, right? It's like the common way. So you've got, let's say, a product sagas where you can load all products, find one particular product, rename it, add a new one, etc. But the truth is that to begin with, you only need the one function that loads in the products. And equally well for every single saga we have and every single reduce and pretty much any part of our application, we did it by features and not by when the code needs to be ran. And I realized that in order to change the performance for real, this is all like first steps, that's great, but what the next step needs to be is a huge scale refactor of all our code into being written in such a way that we can only require what we actually really need at the time we need it. And that will be a lot of work. So don't follow my mistakes. Always measure first before you do talk on performance and tell people what to do. And then realize that it doesn't work. Now, the important thing is, like, be wise about optimization. I think, like, we all are trying to look for quick wins. We are all trying to, find that one tutorial. But the truth is that a lot of it is just about working with React and with JavaScript in a smart way. And that is not, that's not rocket science. It's quite common sense. But that's kind of what it takes. It's a lot of work, unfortunately. But that's everything I've got. Thank you very much.
Now you're probably going to get a lot of questions. Anybody? I think it was just quite a lot to process, to be honest. So this is one of those talks that then you have to take a week off and just pretty much go line by line and see and check in your code. Does it actually make sense?
I will share the slides for sure, so you can like go back to everything that I just said.
Okay.
It's like pretty generic question. Like in one of the slides, you mentioned the method get derived state from props, and I know like it can be like very opinionated whether like you should use it or not. Just what's your opinion about that?
I think it's good that it's opinionated because the previous versions of React allowed you to do a lot of things that weren't very performant. And as I think I hinted at that, like I don't think that we should ever set state based on props. Like that to me is a little bit of an anti-pattern because you already have the information somewhere. So I think it's quite unusual that you would have to do it. I know that there are moments, but they are usually the moments where get derived state from props is actually useful. So I'd avoid it if possible, essentially.
Have you tried actually reading the bytecode which Node.js spits out? You tried that? Okay.
We didn't try reading the code itself. What we did though is like get one of those graphs to see like what is actually in the bundle, like what takes how much size is. That's not what you meant. No, okay. Is it important? Should I do it?
Going really deep, you can do it.
What is the advantage?
You can actually see how much. So how JavaScript it compiles everything to bytecode and then it slows it up. So certain way of using or comparing things makes bytecode larger, so your spin-up time is like longer.
Oh, cool! Very cool.
You set up like linting rules to actually avoid that.
Nice.
It's going really deep. It's like.
No, that's exactly what we need. See, this is exactly what happens every time. Thank you.
Sort of like almost like two-way data binding, we learning from her, and then it works the other way around too. Any more questions?
First of all, just want to say thank you. I feel like there's a whole lot of really hard-won lessons there that are really valuable. But a fair number of them felt like things that could be picked up by a linting tool or some sort of static analysis. Have you ever considered maybe like building something that picks up on some of these and maybe just suggests this is a potential performance bottleneck? Maybe consider this or.
I haven't until now, but it's a great idea. So yeah, I'll actually look into it. I think that's a brilliant idea. Thank you.
Thanks for keeping me fit. Who's next?
Oh, I got a non-technical question. I just saw this action on your presentation. Do you know why?
Sorry, what? I didn't really understand the question.
The Samuel Jackson on your presentation from Pulp Fiction.
Good luck with that one.
Super easy. It says example.
Ready?
Please don't ask me about the gifts.
No, it's all good. From what I can tell from what you were saying about just sort of React in general, having state globally is bad. Is that about right? I mean, it seems to be that like we should be keeping our state as local as possible unless we really don't need it.
In a way, yes. That's kind of why we said that MobX would solve a lot of these issues because it doesn't have that. But to me, like going from Flux ages ago to Redux, the important thing was that you have one place where you store data, and that was really useful to reason about the app. The fact that you have single data flow makes it sort of easier. So that's an absolute trade-off. I think that if you work with the global state in a smart way, it's still doable. But maybe some sort of a combination of the two might be the best approach eventually.
Sorry, just really, really, really quickly, if I could just add something. Sorry. Firstly, thank you. But doesn't that technically mean that like something like context is good then? Because you would only use it if you need to, even though it's bound to re-render something. But if you sort of take that into account, then if you've got something that needs to be global, you should use context. But if you don't, then you should just use React state or use state, I guess.
So I wouldn't use like the context globally exactly for that reason that it would re-render a lot. But I totally agree with you that it depends, like, you know, we should mix and match technologies based on what our needs are. And that's kind of why I try to do this talk a lot about like why things are happening so that people can decide for themselves when to use what. But you're absolutely right, like combining things is good.
Annabelle?
Sorry, it might be a bit of a trivial question, but so you mentioned, so on optimization topic, you mentioned the inline, what was it? What was the method?
Automatic inline requires.
That's the one, inline requires, sorry. So on that part there, doesn't that also cause for cross-checking on terms of what's available and what needs to be used? So in execution terms, maybe for the gentleman with a binary question there, doesn't that cause more execution times?
That kind of what that's true, but what RAM bundling then does is sort of preloads things. So using inline requires together with RAM bundling is a really powerful combination. Having said that, we didn't actually find any huge performance gains or drops between not having inline requires and having them, and then having inline requires and then RAM bundling. And I think that is due to what I said, like the fact that we structure our code in a bit of a weird way actually prevents us from getting the gains. But yes, you're right. We should use RAM bundling that preloads whatever we need to preload and loads in things later on.
Annabelle? Oh, double whammy.
So it felt like quite a few of your performance issues were a huge number of re-renders based on state changes. Did you ever look into debouncing the re-rendering based on kind of maybe a maximum number of re-renders per X seconds or whatever?
We did think about it, but then from performance point of view, you kind of don't want to debounce stuff because that slows it down, if that makes sense. So what our main goal is to prevent the re-renders from happening at all, because once you do that, you only literally change things, the right things at the time you actually need to change them. So that way it felt kind of like the right choice.
Thank you again, Anna. This is outstanding.